The moment you leave this video, you will have the ability to solve complicated problems within just seconds. A skill you will be glad to have, my chemical engineering friend, because today we will do degrees of freedom analysis in every corner of a system, and this will make you memorize the method like your name. This is the problem statement. The acetone solute water diluent mixture is first mixed together with methyl isobutyl ketone MIBK inside a mixer. Flow chart. A equal to acetone, W equals to water, and MIBK, methyl isobutyl ketone. This is acetone and then water, contacted first with the solvent, methyl isobutyl ketone, inside a mixer. It looks like a balloon, but let's assume it is a mixer. Going back to the question, a new keyword, a portion, which means some of the acetone in the feed will transfer from the aqueous, which is the water phase, to the organic, which is the MIBK phase. We will have a stream of A and then W and then MIBK. All of them got mixed together inside the mixer. The mixture passes into a settling tank where the phases separate. The phases, which is the aqueous, and the organic, which is the MIBK, they will be separated and they will be separately withdrawn. This stream that contains A, W, MIBK will go inside a settling tank and it will separate three components into one phase. This phase will be the aqueous phase, which contains water, and the other phase is the organic phase, which is the MIBK. And it was mentioned that the portion of the acetone in the feed will transfer from the aqueous to the organic phase. We will have a small amount of acetone here, and acetone will go with the MIBK. Another keyword, the phase rich in, which means has a lot of, many of, and in this case rich in the diluent, which is the water. We will call it raffinate, is a term we use when the diluent concentration is high. On the other hand, the phase rich in the solvent, which is the MIBK. And when you have a lot of solvent, then this will be called the extract, as you will see later on in the separation course. Now, this is what we care about. The mixer-settler combination. Both the mixer and the settler will be a stage, and we will call it the first extraction stage. This indicates, you see this mixer and settling tank, this is extractor 1. The raffinate, the stream that is rich in water, will pass to a second extraction stage, which means we will have another mixer, we will have another settling tank. This is the raffinate, and it will pass into another stage of the extractor. So we will have mixer, and then it will go immediately to a settler, as the question said, where it is contacted, mixed with a second stream of pure MIBK. This stream, raffinate, will go and be mixed with another stream of MIBK, which is pure MIBK. Mixed together, forming something here. We will separate it into one stream that is rich with water or rich with the diluent containing some of the acetone, a portion of the acetone, and the other will be rich in MIBK, which will also have a portion of the acetone. But here you will have it higher. Acetone will be higher here, because the objective of this process is to separate acetone from water using MIBK. So we'd expect, as we go from stage to stage, the number of acetone going with the MIBK, we'd expect it to be higher than the number of acetone going with water. And also it said it here in the question, leading to a more transfer of acetone. The extract, another keyword. This is the extract, MIBK. And also this one, MIBK, the first one. What about them? Are combined, and you know what is combined, mixed and fed to a distillation column. Fed means entering. This will be the second extractor. This is extractor 1. This will be extractor 2. Both of them will be mixed together now. So we'll take this and we'll take this and we will mix them together in an ellipse shape mixer, and then they will go to a distillation column. It will be separated into two streams. The overhead, which is this one, is rich in acetone. It has a lot of acetone, very high amount of acetone, and we have also MIBK, but it will not be as high as the acetone. Continuing, and the bottom, this one, is rich in MIBK. The majority is for MIBK. For every 100 kg of acetone, water fed to the first extraction, this one, which means if is 100 kilogram, then the MIBK stream going to the mixer of the first extraction stage will be 100 kilogram, and the MIBK going to the second extraction stage will be 75 kilogram. It's clear, if you want to have very simple calculation, then you would choose your bases as 100. Assuming we filled all the information, find the unknowns. But before that, simplify the flowchart, make it simple enough for us to calculate every single information. I didn't write it here in the question, but it said that we have a mixture of 0.5 acetone and 0.5 water. It will come to the extractor one, mixer acetylene combination. It will leave, and it will have a certain composition of acetone, XA, XW, and 1 minus XW minus XA. This will be X MIBK, expressed as X of water and X of acetone. We will have an MIBK pure stream. X MIBK here will be 1 because it's pure, and it will leave as the extract 1, which is this one. We have this stream that will go into another extractor, raffinate. So it will go into another extractor, will leave with some amount of XA, XW, and 1 minus XW minus XA. And there will be another stream of pure MIBK, which is this one. If it is pure MIBK, then it should be 1. It will leave as the extract. This extract second and this extract first will be mixed together. They will be sent to a distillation column. The overhead will have XA, XW, and the remaining will be XMIBK. The same composition will be in the bottom stream. Going back to the problem statement to write every single information we have. The extract from the first stage contains 27% weight with acetone. This is the extract from the first stage, 0.275 of XA. The second stage, raffinate, has a mass of 43.1 kilogram and contains 5.3 acetone. 0.053 acetone, 43.1 kilogram. Also 1.6% weight of MIBK, and lastly 93.1% of water. This one minus 0.053 minus XW, we actually have it. It's XMIBK, and it is equal to 0.016. And we have XW 0.931. Continuing. And the second stage extract, this one, contains 9% acetone, 88% MIBK, and 3% water. We will delete 1 minus XW minus XA because we have it already. If you have it, why don't we write it? Imagine if I draw this in a pen that cannot be erased. Wow. By the way, I'm not doing an ad here. I'm just complimenting the pen. Anyway, we have XA, 0.09 of XA, 0.88 MIBK, and 0.03 XW. The overhead contains 2% MIBK, 1% water, and the balance, it means the remaining of acetone. XMIBK 0.02, 1% water, which means 0.01 water, and the balance is acetone, which means 1 minus 0.02 minus 0.01, which is 0.97 of acetone. This will be M2, XA2, XW2, and XMIBK2, which is 1 minus XW minus XA. This one we don't have the stream of it, M1. This one we have the composition, but we don't have, we will call it M3. After the mixing, we have XA4, XW4, and here it will be M4. The composition here, M5, and the bottom stream will be M6. To simplify the calculation, we would choose our bases as 100. If that's the case, then this will be 100 kilogram entering, and it said in the question, for every 100 kilogram of acetone water fed, we will have 100 kilogram of MIBK fed to the first stage and 75 kilogram of MIBK fed to the second extraction stage. Degrees of freedom analysis. The first thing, overall boundary. You have 100 and you have 43.1, you have 75, you have 100, so you'd expect the degrees of freedom to be, we hope it is 0. If you take this region, the whole region, count the number of unknowns, M5 1, M6 2, XA 3, XW 4. So we have 4 unknowns. And how many number of independent equation? If it is a non-reactive system, then it will be 3. Acetone, water, and MIBK. 4 minus 3, 1. And we don't have any information that will help us to solve the system, so it will just only 1, and 1 is greater than 0. Overall boundary will not do. The second thing, the distillation. This what will come to the distillation, and what will leave the distillation will be the two streams, which is the overhead and the bottom stream. The unknown information will be M4, XA4, XW4, and M5 with M6, XAW, and XA. 7 number of unknowns, minus 3. 4 pieces of information we must know to solve the system. Extractor 2 boundary. This stream coming, M3 stream leaving, XA stream leaving. We have M2, XA2, XW2. This is 3. We have M3, which is 4. We have 4 unknowns, and 1 is greater than 0, which means we need one more information to solve the system, but we don't have it. So extractor 2 will not do. Mixing boundary. It will receive M1 and M3. So we have M1 unknown, M3 unknown. We have XW unknown, 3. M4 unknown, XA4, and XW4. We have 6 unknowns, 3 greater than 0. Moving on, extractor 1, extractor 2, and mixing point. What comes from the extractor 1 is 100, 100, 75, and what leaves is 43.1. Here also the mixer, M4, XA4, XW4, and luckily we have 3 independent equations, 3 minus 3, and it will be 0. We can solve the system if we choose extractor 1, extractor 2, mixer together. But we will continue and see the other situations. To make sure that you mastered degrees of freedom analysis, we will take mixer distillation, what comes from the mixer and what leaves it, and also what comes from the distillation and what leaves it. 7 unknowns will be 4, and 4 is greater than 0. Extractor 1 mixer, what will come, we know it, we don't count it. 100 as well, we know it. M2, XA2, XW2, M4, XA4, XW4, and we have M3 that will come to the mixer, which will make it 7 unknowns, 4 as well. So the boundary of X1 mix will not do. And if you continue analyzing, extractor 2 mix will give you degrees of freedom 5, number 9. Extractor 1 balance will give you a degrees of freedom of 2. With extractor 1, extractor 2 boundary, you will have degrees of freedom equal to 0. So out of the situations we did for finding degrees of freedom analysis, only 2 of them gave us degrees of freedom 0. This is one of the hardest questions you will see in your CHE basic course. None of the questions you will face will be something like this. Before I record this video, it took me 10 trials to find what will be the degrees of freedom equal to 0. And I found that only 6 and 10 will do. And if you have anything additional, maybe you noticed it and I didn't notice it, please leave it in the comment so that I also learn from my mistakes. By trying to solve, you choose either extractor 1, extractor 2 mixer boundary, or extractor 1, extractor 2 balance, x1, x2 boundary, overall balance. But we will not be able to solve because the overall balance, we will have 2 unknowns with 1 equation. Let's do something that will cancel the unknowns. For example, if you do water balance, still you have here some portion of water. So you would not cancel M3. And you would not cancel M1 because you have some portion of water. For example, acetone balance. But still you have M3 acetone portion, and in the M1 you have some portion of acetone. So if you do component balance, choose water or acetone, you would have another equation and you would solve simultaneously for M1 and M3. Let's do boundary around X1, X2, and mixer. Remember, we did degrees of freedom analysis and we found this also having degrees of freedom 0. We have 100, 75 will equal to 43.1 leaving. We have also M4 leaving plus M4, the overall boundary. Notice the wonderful thing here. The only unknown you don't have here is M4. If you do overall balance on the X1, X2 mixed boundary, the answer 231.9. If you do water balance, 100 times 0.5, which is the composition of the water in the feed, you see this 100 and this 75, they will be 0. It will be 100 times 0, which will be 0, 75 times 0, which will be 0, which will equal to 43.1 times its composition, 0.931, plus M4 times the composition of water, or we can write it as M4 of W, because it's the same. 9.87 kilogram. We want to get rid of this 175, so we would do acetone balance, A balance, and I hope you all get A plus. 100 acetone is 0.5 in the feed, if you remember. It's very a long problem, or I made it long. Plus 0 will be equal to 43 0.1 times 0.053 plus M4 times X acetone 4, which will be Ma4 equals to 47.7 kilogram. And now, my chemical engineering friend, you don't have to do the complicated MIBK balance, because once you have the total and you have the chemicals masses, then the remaining mass will be, if you take the total and then subtract it, 9.87 minus 47.7, because this will be the remaining mass that you want. MIBK 4 will be the remaining of these masses, which will be 174.33 kilogram. So we did find the streams of the one that is after the mixing. Here we don't have to find the compositions, but if you want to find the compositions, all you have to do is to take the single mass of the chemical divided by the total to find the composition. Repeat the same thing and you will find it. Now we will say the X1, X2 balance to find M1 and to find M3. Choose a chemical that would not cause us any trouble. Try water. Oh no, we don't have water. We are forced to do acetone. We have to do simultaneous solution, sadly. Use a system of equation to cancel M1 or M3 to solve for M1 or M3, and if you do that, M1 will equal to approximately 145 kilogram, and simultaneously M3 will equal to 86.6 kilogram. We have M1, M3, M4 and its chemicals. This is, by the way, acetone balance. This is the overall balance. Now you could do a water balance, because you do have M1 and M3. XW1 will equal to all of this value. You would divide it by 145, 0.05. We were given 0.275, the mass fraction of acetone in M1 stream. If you have it, then you will say XMIBK will be the balance. The answer will be 0.675. I did this one before to run away from the possibility of having the simultaneous solution, but in this example you are forced to do simultaneous solution. So if you have it, M1 and M3, there is no need to do such a complicated unit. You would notice I didn't come to the distillation, because not all the problems are solvable, sadly. The distillation, if you do balance, even with the known information that you have, with every situation of the 10 trials we've done, you cannot solve the distillation, sadly. Unless the question didn't give us something that we can use it to solve the system of the distillation, the problem will stop at here. The last thing we have, other than the distillation, is to find M2, XA2 and XW2. And if you find these two compositions, then the remaining will be X-methyl isobutyl ketone, MIBK. But I'm gonna make you do it yourself, but I'll give you some hint. You can either use extractor 1 balance or extractor 2 balance to make it easier for you. Imagine, for example, if you did find M1 here, and then you use this extractor 1 to find M2, XA2, XW2. You would use an information that you found yourself, which could be wrong in the exam, for example. Maybe you did some calculation wrong, which makes this M2 wrong as well. So when you choose a balance, make sure that you choose the one that will give you as well the minimum number of the things that you found already. Like here we have M3, only the M3 we just found it. But here we found M1, XA. If you use it to calculate M2, maybe this is wrong. You did something wrong. So this one will be also wrong. But here, if you choose this balance, extractor 2, you have 75 given, 43.1 given. So even if this M3 is wrong, the answer will not be very, very wrong. You see? So M2 will be close to the right answer, because you used information given to solve for M2. Just a hint. If you use it, okay. If you don't use it, the concept is what is important for me. But you get the idea now. The physical non-reactive system. It's not hard if you do degrees of freedom analysis. But before that, you need to do flowchart and labeling every single information to make sure that when you do balance later on, you don't do balance wrong. Even if you are excellent at doing material balance analysis, if the labeling is wrong, then you will not be able to solve. And once again, this happened to me before. I think I got full mark at that, but my instructor shouted at me and said, "You did every calculation wrong. Every single number is wrong." But you understand the concept very well. That's why he gave me full mark. But be careful, not all the instructors like my instructor. He was actually, and still, one of the greatest instructors I have ever known so far. The next video we will talk about the reactive system.